Okay, so we're now. All right, about Unix file permission. Change the title of the seminar because today I just want to emphasize on Unix file permission and the other topics about searching and search patterns. Actually, it's can be by itself and rather uh, as one seminar just to talk about it because it can be quite interesting because search patterns they might take time to understand. So today I'm just going to focus on Unix file permissions and why are they important. Here's some of the different topics that I am planning to talk about today. Um, so, well, probably you have already seen this. These are options from where to go if you want to use Unix or Linux. You can always log in into your own machine, Unix machine, or load Linux running from the internet and run it on your computer. You always install Sigwin if you have a Windows computer, and you can use that online terminal emulator, which is actually using today, just to make it simple and not have to install anything. And the examples are actually quite simple. All right. Let me start saying that Unix is a multitasking and multi-user operating system. It's a multitasking operating system because the operating system allows more than one program to run at the same time, concurrently in the same hardware, in the same server, in the same machine. And it's a multi-user because it allows more than one user. I mean, remember that this is expensive equipment like a supercomputer. Well, you have a supercomputer. You will want more than one user to use it, right? So Unix will have to have the tools and the utilities and the framework to allow more than one user to use the expensive machine at the same time. Here are some commands, Unix commands related to a multi-user operating system. I couldn't find another name for it. I just want to mention that the last three entries on this list, the ones on the bottom, su, sudo, passwd. These commands can be useful, for example, for me. I'm a consultant, and whenever I need to check things in other users' accounts, well, I'll use this command. For you on a supercomputer like Kraken, you won't have access to these tools. But you have your own, Unix machine, your own cluster, and you may be able to use commands. Be helpful, for some particular reason. But whenever using an HPC resource like a computer, only systems and user support are allowed to run this command. And this one, well, the last one is also available on any Unix system. On run Unix box, you can use the password user command to change the password. It happens on a supercomputer like Kraken, and you can actually do the work. Why? Because Kraken is part of something bigger called C. So changing password is actually a little bit more complicated. For a system like Kraken, we use something called OTP, which is a different type of authentication. I just want to show and today I'm gonna talk. I'm talking about the first comment ones on the top. So let's see what happens when I type ID on my terminator. It will return this output. So there are like three fields. The first one has information about what my user name on this emulator. In this case, for me, we will use a 16. If you log into the same terminal emulator, you will get a different username. And I think even every time you log into this emulator, you will get a different account. The field will shows me the name of the group name I belong to. In this case, for the system, it's called web user. Another field will have a list of all the groups I belong to. In this example, there is only one. So web user is working on a real system, like a supercomputer, and it will be the list will be longer because usually all the users will end up belonging to different groups because they are doing collaborations or they are members of different allocations, and therefore you will end up having access to this wallet will be longer. Why is this information important? Well, because when I do the dash LA, you can see that there are um, a lot of files available from my current home directory. All of these have a .NET form. That's why you can't see them with a regular LS. And well, today I want to talk about the information on the first column. So the RWX dash dash dash. They something. They are the reason. And well, I just want to emphasize on the third and the fourth column. The third column is says user. That's because my home directory, which is name dot and all the files like .bash underscore, those files to me, and I can sure that they belong to me because the user ID of the owner is my user ID, and the group name for those is the same as my group name, where user. That information may or may not be important, but as you start sharing files and then you end up in where somehow you don't have access to your files, or you want to ensure that not everybody but a certain group of people has access, well, that's when you have to take care of documents. Otherwise, well, probably you don't care about it. As I said, we are going to spend some time talking about the first column, the information on the first column. What do the RWS and dashes mean? That field contains 5 attributes of any file and all directory available on my system. The file attributes are represented by 10 characters, and there are 4 fields. The first field has 1 character, and the other fields have 2 characters. One on the left, that's going to be called the file type, and the 3 will contain the read, write, and execute permission for user, the owner of the file, for the group of the user of my, like me, my group, and everybody else. What type of file types are there? What type of information can I put on the very first the file type? So that you can have these values. The dash means it's a regular file. So, for example, the dash, this will show you that this information is from a regular file. There was a D that will mean that it's a directory. If we go to the terminal, you can see that there is a D for the 2 lines, because the first 2 lines, the dot and the double dot, those point to my current directory and my parent directory. And the first field has a D, so those are direct. And then for the other system files, bash dot bash on the profile, they only bash because they are regular files. There are no other values like L used for symbolically. That so if one of my files was a symbol, then the first field will have an L to indicate that that's a link, not an actual file, I won't really spend much time on symbolic names, but I want to make sure that, that that will show you what is doing or not. And there are other special files. Remember that I did before on my first seminar on Unix about everything is a file unit. So each terminal, this can be a file, but they are not standard files, they are special files. So when on those files, they might have the C or a D in front of it for the file to indicate that this is a file that handles information either as a stream of bytes or as a block. A byte would be like terminal, and the like a hard drive or CD-ROM will handle blocks. Permissions are there. So this will show you that there is RW, R dash dash, R dash dash. The R, depending on if you're talking about a file or a directory, we have will indifferent information. R, a file means that I can read and open the file. Whereas the R means that I can actually read or see the content of that directory. If the is there. So file means that I can write, I can modify my file. For a directory, it means that I can create and rename and I can delete files in that directory. And the X means for a file that I can execute the program, that the file can be treated as a program. And remember from the previous seminar on shell scripting, that I had to change the file permissions for all the text files that were shell scripted, because that file is a text file. In order to be created a program, it has to put the X attribute in it. Otherwise, the system will not allow you to run it as a program. And in the case of the X allows you to enter a directory. We'll have some examples later on, so you can actually do it on your life. We do the example, and we also explain this information. So the file permission can also be set via an alt representation or symbolic representation. For the left, you can set, for example, the octal 0 corresponds to dash dash, means like nothing, nothing has been set. The one actually will indicate that the file mode being used for X position, the execute position is going to be turned on. The node points to the second position on my field, which is going to turn on the right flag. The 4 will point to the read attribute in the third field of the file mode. And then you can make combinations between them. For example, octal number 2. No, I'm sorry, 3. Octal number 3 corresponds to W and X from together. And then you can see the bottom of the list and other options that you can try. And so one way, so if you know what are the 5 attributes that you want in a specific file, instead, like, work out how you're going to express it. But one way to express that information is via octal representation. We'll see with the example how it works. And then there is thing about symbolic representation. Well, it's a little hard to think on octal representation and specific flags want to turn on and off. Well, there is a symbolic representation that will allow you to turn on the properties depending on, for example, if you use a U, U will mean the U, the owner, G, group owner, O, everybody else, and A is everybody. how do you set the file permission on a, well, there is a Unix command called chmod. Ch will receive as an argument what do you want to do and what is the name of the file. For example, using chmod. So on the first example, I'm using the octal representation. So if I execute chmod as the Unix command to change the file permission, and then pass 600 the name of my file, which is full.txt. If I do, then only the owner will be able to read and write to this file. I won't be able to execute. If you go back to the list, remember that the octal 6 will only turn on the R and the W, but no S. That means read and write, but I cannot execute. And the mirror off means that nobody else, nobody from my group or anybody else will be able to access the file. Let's look at the 7.5. 7.5 is a common flag used for programs. Why? Because 7.5. Let's look at 5. Let's look at 7. I need the owner will be able to read, write, and execute this program. The 5 means that everyone will be able to read and execute this program. And again, this means that, again, everybody in my group, anybody else will be able to read or execute this program. So, it's common that whenever you create a program, you will set the file permissions like that, so it's such that you can delete anything with the program and somebody else can actually execute it. So if you feel comfortable using octal representation, it can be actually quite easy and quick to change the file permission. If it doesn't make much sense yet, well, you do the symbolic representation. So the third example starts with you need the user, and then there is plus. You can have a plus or a minus. The plus stands for turn on whatever is next. In this case, it's called next. Name of the file. So with that example, all I'm doing is add the execute permission only for the user. We'll example later on. Let me just explain this example so that we can do real example. We can see the real life. Here, the next example, that's the equivalent to the very first one, to the very first example. When me, the owner, I will be able to read and write. You can see the option with me, the owner. When there is a plus, it means that I will be able to read and write. And comma, because you can have multiple actions with the same command. G is for everybody in my group, and the O is everybody else. And then sign will indicate that all the flags will be equal to 0 or turn off. Therefore, that one will be equal to the first one. And then the last, that's an example. That's the equivalent of the second example. Use the 755, the octal 755. When you have to read it, it starts with a plus, means that everybody will be able to read and execute this file called program. And else, they will not be able to write to it because it has minus W. So let's do those examples on the so we can see know this is true. Right. Well, we can use this information. So, for example, remember I said that every time you log into this into terminal, you get a different account. Please, if you can try to open a terminal, doesn't matter which system you use. For this example, we are doesn't matter. So, how to get a file? I'm gonna use a command called post that and file is called foo.exe. That just get my file. It doesn't contain anything, empty. But for my example, that's fine. So when I do a ls-l, here's my file user, foo.exe, user 077, and right now I first it means that so I can read myself. I am able to execute this file, and everybody in my group is able to read it, and everybody else is also able to read this file. If I want to change the permission such that only me is allowed to read this file, I use the chmod command at 600, name of my file. Again, 600, the 6 is the file permissions for me. The first 0 is important for everybody in my group, and the last or third 0 is for everybody else. So 6 will be translated into read and write for me, and 00 is nobody else benefits. Okay, so let's do it. Let's check ls-l. So now you can see that the file permission has changed for my file. So now the only one who can read and write, I cannot do it, and nobody else, not even people from my group, can do anything with this group. Create another file program. Let's imagine that this was a real program, like a shell script, for example, and it's called program. So, but permissions are those R and R. I mean, I can read and write to it, and everybody can read to it. If I make this program executable, example like this, in order to execute, the system will tell me that you can't execute it because it's not a program. How can I make them? Well, I need the execute flag. So to do this is by doing this. By one thing is for me, yes, as the owner of the file. That's translated into I can read, I can write, and execute this file. This is for everybody in my group, my group, my Unix group, which they can read and they can execute the file program, and the other will be everybody else can also read and execute the program. So then with ls-l, you file permissions have changed, and the first column you can confirm that actually this is true. I do everything with it. Everybody might can read and exit the program, and everybody else can also do it. With that, I want to restrict access to only me and people in my group. So how do instead of using 755, I will use 750. So now it has changed. And first you can see that again, I do everything I want with it, and in my group, anybody can read and execute, but everybody else not in my group will be able to do anything with this file. Let's try with another example. Hello. Hello.sh. So /l, my file hello.sh. Once again, I can read and write, and everybody else can read it. If I want to use symbolic representation and make this file executable, I can use command and then the presentation which will be you, me, the user, the owner, and the plus from the x, the execute the attribute for this file, and then the name of my file, the output. So now my file, I mean, like almost everything is the same except for now my file is executable only by me. We can do the examples. Was the only owner didn't write. So for example, let's do the example. Only owner can read and write using symbolic representation. Okay, the mode dot those comma dot equal. So how do you read this? The U stands for me, the owner, plus means I want to be able to read and write. Everybody else in the group, or it doesn't matter, anybody else out my group will not be able to do anything with it. So that on the page, then /l, here you can see that yes, I mean the permissions have changed. RWL there, but the read attribute from this one, and if you don't want this file to be executable, you know, change it by example, me the user. I don't want this to be executable, so I'm going to remove the X property. So now the X is gone. So handling the file, and you need to change the permission. That's how you do it. I also want to show you, like, for directory, let's make directory, for example, called 10. This is my listing, and in the front of the first, which, you know, yes, temp is a directory. This is the temp, the cd command, and let's create a file. And there's another file. Hello. So this directory, now I have two files. I write to the file. If I back to my, or the parent directory of temp, I can have temp, for example, and I can start two files. What the attribute of the public temp? Well, it's a thing. I can read and execute from directory. My group can read and execute that, and everybody else can also read and execute. Everybody else can also look at the content from this. Yes. You got looking for it. You did? I'll need it for another minute. Okay. As long as we know where it's at. Okay. Sorry, so in my group can change into that directory and see the content, like to an LS. So, if, the same as the file, I can always, for example, change it like this, for example. I don't know. I have to do because it'll actually ask the LS to treat the file. Don't show me file subdirectory. So I'm the only one who can actually do and write and execute into that directory. Now let's properties from this directory. For example, I'm going to move the X from the directory. So now when I do this, you see the X on. So now I try to do the ls-m. Look at this. And if I, yeah, okay, let's put it back. Now remove right on them, and I can file and change into them. Yes, and I can fill my files. But let's try to create another file, whatever. Create a new file. So this just you that files for me are important, and it's to work in a multi-user environment, and especially when you are going to share your files with you. I just briefly mentioned that files special permission type. You can look at this, read it, may be important. This should be important, for example, when you're a sysadmin, or for example, when you want to create a subdirectory where you have files that you are sharing with somebody else. You can look at it. I don't know. Depends on what you do. You can or cannot. That is important. They can be used if needed. Here's something else I want to mention, and it's called the UMask. So, UMask is something. It's a command that will allow you to change the default file permission. Any file that gets created. So you can see that when I type UMask, we can run this on the emulator because this from the emulator itself. So let's go to the emulator. So the default value is 0022. The way is that UMask, what the value that you have specified in UMask is going to be used to remove the permission from whatever is the default. So the default for UMask is 0022. So my terminal is about to expire. So let me open let me close this and open a new one. Sorry. New terminal. That's fine. So the UMask value for this system is 0022. File like full.txt. You can look at the content. So the default permissions are I can read and write, and every group and everybody else can read. Let's see what has changed the value of UMask to 000. Like, it won't do anything. So if I create a file, this, you can see that the default file permissions are actually different, because now it's doing nothing. So by default, in the file, file permissions are set such that I read and write, in my group can read and write, and everybody else can read and write. Now, I don't want anybody else to be able to write from my file, because maybe security purposes. I can an octal value like this, 0006. I use the value for UMAS, 0066, and create a new file. The output from this, you can see that now my new file, the default has changed, because now I am the only one who can read and write for it. So it can be important if you are careful about the file permissions from the file by default. So if for some reason you want to make sure that nobody else will be able to read and write an entity program by default, then you have to set up the UMAS properly. So the UMAS value is the octal value concept is about the same. So what the 66, in this case 666 will mean write. Remember the little table we have here. 6 we're going to read and write. Any value is for the octal. It's going to work with that chmod will turn it on, whereas UMAS will actually turn it off and turn it off. Yeah. So one last thing is the change owner command. The change owner command is used to change your file. Here you can sample that, for example, I have a file called foo.txt, and I can indicate a user ID and group name to change the values for the file. So in this case, for foo.txt, I can change the user owner value in operator, and you can also from this that you get now the belongs to somebody called operator, and I also change the group name of my file, which in this case is user. So now my file belongs to a user called operator into users Unix group. So that be important if you are going to share a file with somebody else, and you change the information of the member with how you do it. Well, this is it. This is for the Unix file permission. If the questions, please use the chat. And well, I hope that you found this useful. And on a next, on a future session, we'll cover the topics about patterns and how to export files. It's actually quite thank you.